everyone. In this video, we are going to see about Kirchhoff's laws, which is a very important topic in Unit 1 of Electric Circuits Analysis subject. First, we'll see what are the types of Kirchhoff's laws. Kirchhoff's law is of two types. One is KVL and the other one is KCL. So, KVL means Kirchhoff's voltage law and KCL means Kirchhoff's current law. So, first we'll see what is Kirchhoff's voltage law. Kirchhoff's voltage law states that the algebraic sum of all the branch voltages around the closed circuit is 0. So the key word here is closed circuit. So any circuit which you consider to be closed, the algebraic sum of all the branch voltages is 0. Okay. So it can also be written in terms of sum of the voltage rise is equal to sum of voltage drop. I'll tell you about what is voltage rise and voltage drop while explaining about this sign conventions. Okay. So now let us see. Let us apply KVL for the loop ABCDA. So I have taken a small simple circuit like this in order to make you understand about this how to apply KVL. Okay. So it has got 4 nodes A, B, C, D. Okay. And the loop here is to be considered as A, B, C, D, A. Okay. So how many branches are here? This is one branch, second branch, third branch and fourth branch. Okay. And E1, E2, E3, E4 and all represents the voltage sources. So voltage source can also be represented in terms of V. Okay. So E can also be the representation which mentions EMF. Okay. So here I've got R1, R2, R3, R4, which is nothing but the resistances. So I1, I2, I3, I4 and all is the current flowing in the branch. Okay. So when you need to apply the KVL for this loop, it can be written as the summation of EMF. EMF means how many voltage sources you have? 4, right? So the summation of the voltage sources is written as summation of EMF plus summation of I into R. What is I into R? Generally by Ohm's law states that V is equal to I into R. So the voltage across the resistance can be written in terms of I into R. So see here it is written as summation I into R, which is equal to 0. So by this entire equation we say that the sum of the entire voltages, that is of all the branch voltages in the closed loop, is 0. Is it proved here? Now, how to write about this summation of EMF and summation of IR? So, that is only written in first and second equation. Before explaining about this, I will first explain about the sign conventions. Okay. So, see here you have got a battery. The longer line will always represent positive and the smaller line will always represent negative. So, here is the current direction. Okay. Arrow mark is given. The current is leaving at positive terminal. So, the sign should be is plus V1. So, always remember the sign convention for writing this voltage sources. No? For that, you have to always remember the leaving terminal sign. So, what is the leaving terminal sign here? Plus. So, you have written it as plus V1. So, this kind of current leaving from the negative to positive is called to be as voltage rise. So, see here V2 has got negative, the smaller line represents the negative and the longer line represents positive. So, the arrow mark here, that is the current flow. So, the current leaves at the negative terminal. So, what will be the sign here? So, it should be as minus V2. So, whenever current leaves from plus from here and leaves at the negative terminal, that point is called to be as voltage fall or voltage drop. Now, you can also write the sign for applying across the resistance. If you want to find out the voltages and all, there will be branch currents. So, you see here you have got a branch current and this clockwise direction current, no, this is called as loop current. So, whenever this loop current and the branch current are in opposite, see, can you see here the opposite direction? That time you have to always use positive sign. And whenever you apply KVL for the branch, if the branch current and the loop current are in same direction, you should mention in negative sign. So always feed this in your mind that if it's the same direction, it's a negative sign, and if it's a opposite direction, it is positive sign. Okay. Now can we apply? Yes. Summation of EMF. So concentrate only on the voltage sources that is mentioned as E1, E2, E3, E4. How should you write? You should write in terms of the leaving terminal sign. Okay. So can we start? So this E1 is a first voltage source, and this loop current is leaving at which terminal? Negative. So it is mentioned as minus E1. Next, it is leaving at plus. So plus E2. Next, it is leaving at minus E3. Then finally for E4, where it is leaving? It is leaving at plus, right? So it is plus E4. So that is only the first equation. Next, can we write it for each resistances? Yeah, summation of I into R. Now concentrate on the branch current and the loop current. What about these two directions? Both are opposite. Opposite means what sign has to be used? Plus. So plus I1 into R1. Then, can you see here? Plus I1 into R1? Yeah. Next, can you move on here? Yeah, this I2 and the loop current are in same direction. Same means minus sign. So minus I2 into R2. Same way can we apply here? This is also same. So minus I3 into R3. And this is also same. So it is minus I4 into R4. So that is second equation. So now apply this first and second equation to this overall equation. Yeah, here it is applied. Correct? So therefore the equation becomes like this, which should be equal to 0. So this is how you have to apply KVL for the given circuit. I hope you would have understood by this explanation. Here certain rules are given. So whatever I explain now in words, that is given as a statement. Okay, if you want, you can read this and understand clearly about this. So I've told everything about wherever you should use positive sign, wherever you should use negative sign, everything is being clearly explained. Yes, now we are moving on to Kirchhoff's current law, which is represented as KCL. So for example, I have taken a single node and 5 branch currents here. So current law will deal with current, right? So how many incoming currents are here? Incoming means the arrow mark should be inward. Okay, so towards the node. So I1, I2, I3 are incoming current towards the node, and I4 and I5, the arrow marks are outward, so they are the leading currents. Now let us see what is Kirchhoff's current law states. KCL states that the algebraic sum of current meeting at the junction is 0. So junction means it's nothing but it's the node. Okay. So the algebraic sum, so the addition of all these currents at meeting at a junction, that word is important, is 0. Or in other words, we can also write it as sum of current entering through the node is equal to the sum of the current leaving from that node. Yes. So that is what I've explained you in the beginning itself. What are the incoming currents and what are the outgoing or leaving currents. So now can we apply and see what are the incoming currents? Algebraic sum of what are the incoming currents? I1, I2, I3. So I1 plus I2 plus I3 equal to what are the leaving currents? I4 and I5. So I've added. So you can also bring this I4, I5 to the other side and write the equation as the sum of all the currents meeting at a junction is equal to 0. So here another circuit is also given for your understanding. So you have got a voltage source, a particular current I is leaving out, and when it enters a node, always remember when a current enters a node, it splits. Okay. So here see it is split as I1 and then as I2 and then as I3. So since 3 branches are here, the single current I is split in terms of I1, I2, I3. So what is the incoming current to this node? Only I1. So that can only I, that is written as I total, which is equal to I1 plus I2 plus I3. So these 3 are leaving current. So it is written here. Okay. I hope by this seeing this video you would have understood about Kirchhoff's current law and Kirchhoff's voltage law. Thank you. And in our next video we will see about the problems based on this KVL and KCL. Thank you.